Lesson 10, Selected Problems from WAEC, Part 1. Example 29. An aeroplane flies from town A on the given latitude and longitude to town B, latitude 20 degrees north, longitude 20 degrees east. Roman figure 1. If the journey takes 6 hours, calculate correct to 3 SF the average speed of the aeroplane. Roman figure 2. If it then flies due north from town B to town C, 420 kilometers away. Calculate correct to the nearest degree the latitude of town C. Take radius of the earth equal to 6,400 kilometers and pi equal to 3.142. Solution. Let us represent the given information on the earth as a sphere. So you draw it, you draw the two principal axes, north south, you have east west. You draw the equator, latitude 0 degrees. Considering points A and B, they have the same latitude, 20 degrees north. That is the upper side of the equator. You draw this as latitude 20 degrees north. It is a small circle. For us to represent the given longitudes, we have to draw the prime meridian, longitude 0 degrees. The two given longitudes are on the same side, east. So let's draw the prime meridian on the west side, longitude 0 degrees. Then you draw longitude 20 degrees east, followed by longitude 60 degrees east. That is what you have in this diagram. The equator, latitude 0 degrees. You have latitude 20 degrees north. You have the prime meridian, longitude 0 degrees. This is longitude 20 degrees east, and the second is longitude 60 degrees east. So if you move from the reference point to this point, that is point B, 20 degrees north, 20 degrees east. If you move from here to this point, you have point A, 20 degrees north, 60 degrees east. The angular difference is simply the subtraction of the two given longitudes because they are on the same side of the prime meridian. Roman figure 1. Average speed is equal to distance over time. Distance AB is along parallel of latitude, which is a small circle, and such a distance is calculated using this formula. Angular difference is 40 degrees. The subtraction of the two longitudes angle along parallel of latitude alpha is equal to 20 degrees. You come here and replace the various parameters with what they stand for. You have it in this form. When you simplify further, you have this result and this result. After division, you have 4,199.11961 kilometers. Therefore, average speed is distance divided by time, 6 hours, given in the question, and you have it in this form. Approximately equal to 700 kilometers per hour. Roman figure 2, you are asked to find the latitude of C. Now, the flight from B to C is along longitude. Longitude is half of the meridian. Since meridian is a great circle, the flight from B to C is through a great circle. So distance BC is along great circle. The distance is given to be 420 over the angular difference over 360 times 2 times pi times radius of the earth, multiplied through by 360 to clear fraction. Divide both sides by the product of these three numbers to make theta the subject, and you have it this form. When you simplify, you have this result. After division, you have 3.76 degrees. Latitude of C is equal to latitude of B, 20 degrees, plus the angular difference. Now, this is the angular difference. You add it to the latitude of B in order to get the latitude of C, and that is 24.76 degrees. To the nearest degree, you have 24 degrees north. Note that due north implies same longitude but different latitude. They are the two latitudes, B and C. They are on the north side of the equator. That is why to get the latitude of C, we have to add the angular difference between B and C to that of latitude B, so that for us to get this in return, you subtract this value, the latitude of C, from latitude of B to get this angular difference. Example 30. An aeroplane flies due north from a town T on the equator at a speed of 950 kilometers per hour for 4 hours to another town P. It then flies eastwards to town Q on longitude 65 degrees east. If the longitude of T is 15 degrees E, a part of the question represents this information in a diagram. B. Calculate the Roman figure 1, latitude of P, correct to the nearest degree. Roman figure 2, distance between P and Q correct to 4SF. Take pi equal to 22/7, radius of the earth equal to 6,400 kilometers. Solution. A part of the question, you draw the earth as a sphere and the two principal axes, north, south, east, west. You draw the equator, latitude 0 degrees through the center of the earth. If you watch again, the aeroplane flies due north. So we have another latitude unknown up the equator in this form. Then we have the two longitudes, 5 degrees and 15 degrees. They are on the east. So let's draw the prime meridian on the west side, that is longitude 0 degrees. Then you have longitude 15 degrees east and longitude 65 degrees east. The point T is on the equator, that is latitude 0 degrees, and that is the point T you have here. Latitude 0 degrees, longitude 15 degrees. This is point P with unknown latitude but longitude 15 degrees. Then point Q with unknown latitude but longitude 65 degrees east. This is the A part of the question. B part of the question, Roman figure 1, latitude of P correct to the nearest degree. Distance between P and T is needed. From the question, the speed and the time are given, but speed is equal to distance over time. You make distance the subject, it becomes speed times time. That is 950 times 4 equal to 3,800 kilometers. Let latitude of P be theta degrees north. It is along the great circle. This point is clearly stated in the question. So along the equator is along great circle. Such a distance is given by this formula, but we are looking for the latitude. The distance is given, so you have it in this form. Distance 3,800 is equal to the unknown latitude over 360 times 2 times pi times radius of the earth. If you simplify, you have these results. To get theta, multiply through by 2,520 and divide both sides by this value to make theta the subject. After multiplication and division, you have 34.01 degrees. To the nearest degree, the latitude of P is equal to 34 degrees north. Roman figure 2 of part B. Distance between P and Q correct to 4SF. That distance is along parallel of latitude, which is a small circle. Such a distance is given by this formula. Theta, the angular difference between the longitudes, is through subtraction. You have 50 degrees. Alpha, angle of latitude, is equal to 34 degrees. You come here and replace all the parameters with what they stand for. You have this result. When you simplify further, you have it in this form and you have this result. After division, you have it in this form. To 4SF, the distance is approximately equal to 4,622 32 kilometers. End of lesson 10.